Hello and welcome back at the Finite Link channel, and now we are at the Build a Small Network Part 2. By remembering that the objective of this material is to implement a network design for a small network to include a router, a switch, and even devices. For the moment, we have identified the devices used in a small network. We have explained how a small network serves as the basic of a larger network, and we even use the output of the ping and tracer commands to verify connectivity and establish relative network performance. And what is left to discuss about this material is to identify the protocols and application used in a small network, use host and IOS commands to query information about the devices in a network, and we even have to describe common network troubleshooting methodologies and troubleshoot issues with devices in a network. The network is only as useful as the applications that are on it. There are two forms of software programs or processes that provide access to the network. We have the network application, which are applications, the software programs used to communicate over the network. Some end-user applications are network aware, meaning that they implement application layer protocols and are able to communicate directly with the lower layer of the protocol stack. Email clients and web browser are examples of this type of application. We even have the application layer services where other programs may need the assistance of application layer services to use network resources like file transfer or network prints pooling. Through transparent to an employee, these services are the programs that interface with the network and prepare the data for transfer. Different types of data, whether text, graphics, or video, require different network services to ensure that they are properly prepared for processing by the function occurring at the lower layer of the OSI model. Each application or network services use protocols, where these protocols define the standards and data formats to be used. Without protocols, the data network would not have a common way to format and direct data. In order to understand the function of various network services, it is necessary to become familiar with underlying protocols that govern the operation. We usually use the Task Manager to view the current application processes and services running on a Windows PC, as it is shown here in this figure. And most of the technicians work in either a small or a large network will in some way be involved with network protocols, where the network protocols will support the application and services used by employees in a small network. Network administrators commonly require access to network devices and servers. The two most common remote access solutions, we have said that there is a telnet and a security shell, where the security shell is the service secure alternative to a telnet. When connected, administrator can access the security shell server's device as through they are logged in locally. Security shell is used to establish a secure remote access connection between a security shell client and security shell enabled device. If that would be a network device, it must support Security Shell to provide remote access Security Shell services to the client. And if that will be a server, it must support remote access Security Shell server services to the client. Network administrator must also support common network servers and their required related network protocols, as they are shown here in this figure. And we have the web server, where the web clients and web servers exchange web traffic using the Hypertext Transfer Protocol. And if they use the Hypertext Transfer Protocol secure, it means that it's used for secured web connection. We have even the email server, where email server and clients use simple mail transfer protocol to send emails, and Email clients will use post office protocols or Internet Message Access Protocol to retrieve these emails. We have even the FTP servers, which stand for File Transfer Protocol services that allow files to be downloaded or uploaded between a client and FTP server. FTP Secure and Secure FTP are used to secure FTP file exchange. We have even the DHCP server, where the dynamic host configuration protocol is used by the clients to query an IP configuration from a DHCP server. They can get from the DHCP server the IP address, subnet mask, default gateway, and more. And as for the DNS server, domain name system resolves a domain name to an IP address and will even provide the IP address of a website to a requesting host. Businesses today are increasingly using IP telephony and streaming media to communicate with customer and business partners. So many organizations are enabling their employees to work remotely. As it is shown here in this figure, many of their users still require access to corporate software and files, as well as support for a voice and video application. The network administrator must ensure the proper equipment is installed in the network and that the network devices are configured to ensure priority delivery. As for the infrastructure, the network infrastructure must support the real-time application, where the existing devices and cabling must be tested and validated. And newer network products may be required at this infrastructure. And as for the voice over IP, these devices will convert analog telephony signals into digital IP packets. Typically, the voice over IP is less expensive than an IP telephony solution, but the quality of communications does not meet the same standards, where small network voice and video over IP can be sold using Skype and non-enterprise version of Cisco WebEx. As for the IP telephony, is an IP phone which performs voice to IP conversions with the use of dedicated servers for call control and signaling. Many vendors provide these small business IP telephony solutions such as Cisco Business Edition 4000 series products. And we have even the real-time application, where the network must support quality of service mechanisms to minimize latency issues for real-time streaming application. Real-time transport protocol and real-time transport control protocol are the two most protocols that support these requirements. In the first material, we verify connectivity and found that some parts of our network is not working as it should. But now, for us, it's time to use some commands to troubleshoot the devices. Host and iOS commands can help to determine if the problem is with the IP addressing of the device, which is a common network problem. Checking the IP addressing on host device is a common practice in network for verifying and troubleshooting end-to-end connectivity. In Windows 10, you can access the IP address detail from the Network and Sharing Center as it is shown in this figure, where we quickly view in the four important settings: the address, subnet mask, router, which means the default gateway, and the DNS. However, network administrators typically view the IP addressing information on a Windows host by issuing the ipconfig command at the command line of a Windows computer, as it is shown here in this output. So you can see the same information by using the ipconfig. And by using the ipconfig all command, you can view the MAC address as well as a number of details regarding to the layer 3 addressing of the device as it is shown here in this example output. If a host is configured as a DHCP client, the IP address configuration can be renewed by using the ipconfig/release and ipconfig renew command as it is shown here in this example. The DNS client service on Windows PC also optimizes the performance of a DNS name resolution by storing previously resolved name in memory. The ipconfig/display DNS command displays all the cached DNS entries on a Windows computer system as it is shown at the slide. By verifying IP setting using the graphical user interface on a Linux machine will differ depending on the Linux distribution and desktop interface. But here in this figure, it shows the connection information dialog box on the Ubuntu distro running the GNOME desktop. As you can see the IP address, subnet mask, default gateway, and the DNS. On the command line, network administrator use ifconfig command to display the status of the currently active interface and their IP configuration as it is shown here in this output. The Linux IP address command is used to display address on their properties. It can also be used to add or delete IP addresses. And as for the Mac host, in the graphical user interface, we open the network preferences advanced to get the IP addressing information as it is shown in the figure. However, the administrator, by using the ifconfig command, they can also be used to verify the interface IP configuration as it is shown here in this output. Other useful Mac operating system commands to verify the host IP setting include network setup, list all network services, and the network setup get info as it is shown here in this following output. We even have the ARP command, which is executed from the Windows, Linux, or Mac command prompt. The command lists all devices currently in the ARP cache of the host, which includes the IPv4 addresses, physical addresses, and type of addressing for each device. Let's refer to this topology that is listed here. And as you can see, there is the switch, a router, and there are 5 computers. And if we use the output of ARP command on the PCA, it will list all the devices connected with the PCA that he can communicate. In the same way that commands and utilities are used to verify a host configuration, there are commands that can be used to verify the interfaces or on the intermediary devices. The Cisco iOS provides commands to verify the operation of router and switches interface. The Cisco iOS at the command line by using the show commands will display relevant information about the configuration and operation of the device. Network technician use the show command extensively for viewing configuration files, checking the status of device interface and processes, and verifying the device operational status. The status of nearly every process or function of the router can be displayed by using this command. If we use the show running config command, we will be able to verify the current configuration and setting as it is shown here in the slide. By using the show version, we will be able to verify the memory interfaces and license of the device. And if we use the show interfaces, we will be able to verify the interface's status and see if there are any error messages. And if we use the show IP interface, we will be able to verify the layer 3 information of an interface. If at the command line we will use the command show arp, we will be able to verify the list of known hosts on the local Ethernet LANs. And by using the show protocols, we will be able to verify which protocol are operational in the device. By using the show IP route, we will be able to verify the layer 3 routing information. And we have even the show CDP neighbor commands. And there are several other iOS commands that are very useful. We have the Cisco Discovery Protocol, which is a proprietary protocol that runs at the data link layer. Because the CDP operates at the data link layer, two or more Cisco network devices, such as routers that support different network layer protocols, can learn about each other even if layer 3 connectivity has not been established. When a Cisco device boots, the CDP starts by default. The CDP automatically discovers neighboring Cisco devices running CDP regardless of which layer 3 protocol or suites are running. CDP exchange hardware and software device information with its directly connected CDP neighbor. The CDP provides the following information about each CDP neighbor device as the device identifier, which is the configured hostname of the switch, router, or other device. We have the address list. It's up to one network layer address for each protocol supported. We have the port identifier, which is the name of the local and remote port in a character string format, such as fast Ethernet 0/0, for example. Capability list, which specify if the device is layer 2 switch or a layer 3 switch, for example. And we have even the platform, where the hardware platform of the device will show the information of the device, such as Cisco 1841 series router. Referring to the topology that we have here and by using the show CDP neighbor command, we have this output. And here it is displayed that the router 3 use the interface Giga Ethernet 0/0/1 to connect to the fast Ethernet 0/5 interface of switch 3, in which there is listed that the switch 3 is a catalyst switch 2960. We can see that the router 3 has not gathered information about switch 4. This is because the CDP can only discover directly connected device, Cisco. And as you can see, the switch number 4 is not directly connected to the router 3 and therefore is not listed in the output. The show CDP neighbor detail command reveals the IP address of a neighboring device as it is shown in the output. The CDP will reveal the IP address of the neighbor regardless of whether or not you can ping that neighbor. This command is very helpful when two Cisco routers cannot route across the shared data link. The show CDP neighbor detail command will help determine if one of the CDP neighbors has an IP configuration error. As helpful as CDP is, it can also be a security risk because it can provide useful network infrastructure information to threat actors. For example, by default, many iOS versions send CDP advertisement out all enabled ports. However, best practice suggests that CDP should be enabled on interfaces that are connecting to other infrastructure Cisco devices. The CDP advertisement should be disabled on user-facing port because some iOS versions send out CDP advertisement by default. It is important to know how to disable the CDP. To disable the CDP globally, use the global configuration command no CDP run. To disable CDP only on the interface, you will use the interface command no CDP enable. One of the most frequently used commands is the show IP interface brief command. This command provides a more abbreviated output than the show IP interface command. It provides a summary of the key information of all the network interfaces on a router. Let's have this example. By using the show IP interface brief, the output displays all interfaces on the router, the IP address assigned to each interface, if any, of the operational status of the interface. With the show IP interface brief, it's a command that can also be used to verify the status of the switch interface as it is shown here in this output. You can see that the VLAN 1 interface is assigned an IP address of 192.168.254.250 and has been enabled and is operational. The output also shows that the fast Ethernet 01 interface is down. This indicates that either no device is connected to the interface or the device that is connected has a network interface that is not operational. In contrast, the output shows that the fast Ethernet 02 and 03 interfaces are operational. This is indicated by both the status and protocol being shown as up. And that was all about the second part of Build a Small Network. Thank you for being with us. Hopefully you enjoyed the video, and if you do, share it with your friend. And for those who are new at this channel, do not forget to subscribe and hit the notification button for the new video that will be uploaded. See you to the next session.